It is 8:30 on the dot, and before I start, I really want to thank you all for 15 subscribers. Just yesterday, we hit 5 and 10 subscribers in less than 24 hours is very, very nice. So, shout out to my number one supporter, the Mayhem. I think you need to calm down, but today's topic, it's going to be multivariable calculus, as I promised yesterday. So let's go and dive into today's video. So problem number one, there's two problems here. Problem number one, two. I have to hurry because YouTube won't let me upload more than 15 minutes, so we have to hurry. So problem number one, before I start, I'll write the formulas as always. X is equivalent to r cosine theta. Y is equivalent to r sine theta. And dA is equivalent to r dr d theta. So before I start, there's something called polar coordinates that we're going to heavily emphasize in today's video. Polar coordinates are basically coordinates of a circle, but in like pi, I guess. So the upper bound, upper UB, from here to here, lower bound LB, from here to here, it'll be from pi to 2 pi, and from here to here, it will be from 0 to pi. So just remember that. And the other formulas are full circle is a full circle is 2 pi. So full circle is 2 pi. Half a circle is just pi. Quarter circle, QS, I'm just going to write QS, quarter circle, is pi over 2. And then 1/8 of a circle, it's pi over 4. So sorry if this is a little bit messy, but you get the point. So now let's begin with the first problem. The first problem says, evaluate where R, the region of inside half circle with a radius of 4, centered at origin, and locate the x-axis. Okay, so half circle, we can already tell that that we're going to integrate one integration with pi. So with a radius of 4, that's all the information we need. So I'm just going to remember, okay, so we're over here. That's the question, I think. Yeah, okay. By the way, x squared plus y squared is r squared. It's also one of the formulas. So this is just the formulas. Okay, now we go on with the problem. So, okay, when you see this r, it's automatically going to be from theta raised to 1, theta raised to 2, and the radius. So the radius said that it was from the center, origin, I'm going to use red. It said from the center of the origin to 4. What that means, it's ranging from 0 to 4. So I'm going to write 0 over here to 4. X squared plus y squared dA. Okay, so you already know most of the formulas. So it said half circle, if you remember. Theta 2 is always going to be the equation for whatever part of the circle it is. So since it's a half circle, it's going to be pi. Okay, so I really need to hurry a bit because 2 problems, 7.5 minutes per problem if I want to even make it to the very end. So I have to be below 7 minutes. So it's going to be 0 because it's ranging from a no circle to half a circle, if you get what I mean. So 4 to 0, this is just going to be r squared, r differentiated with r and differentiated with theta. So this is just going to be pi 0 and then 4 0. So this can be multiplied to become r cubed. So now we just have to differentiate all this with dr d theta. So if you watch my last integration video, you know just how easy double integration is. So this shouldn't even be much of a challenge. 4 0 we're going to first differentiate with r squared dr. We're going to take the first integral, ranging from 0 to 4, dr. So that's just going to be, since there's no constant, as I've told, if there's no constant, it's just going to be 1 outside, so we're just going to put 1 multiplied with r to the 4th, r to the 4th over 4. If you remember the power rule, you have to remember that as well, please. Yes. So minus r 4th over 4. This is not 0. Do not get confused. And this is ranging from 0 to 4. So one of these r's has to be 4. The other r has to be 0. So since 1 is 0, we all know anything divisible by 0 is 0. So we're just going to be left with 64 times 4, which is 256, and divided by 4 should be 64 again, multiplied with 1, 64. So now we're going to move on to this pi 0, pi 0. So when differentiating with theta, since there's nothing here, we're gonna use this. So that simply would make 1. So 64 is the only constant. Pi theta 1, because it's differentiated by theta, d theta. So this and this, there's gonna be 1. So 64 multiplied with pi. And I guess you could actually write 1, but it wouldn't matter because it's just going to be multiplied with 1, because since you're using this, it's going to be multiplied with 1. So 64 pi multiplied with 1, you would just get 64. So the answer is just 64. But I really don't recommend you use this method. It only works a few times in many scenarios. It's best to just leave it at 0. It's more efficient to just leave it as 0. And when differentiating by theta, just move the constant 64 there. And just don't multiply theta with much. Just divisible by 1 should be just 1. So you don't need to make this 0 theta anyhow. So yeah, just don't do that, but it works in a few scenarios. So the answer is 64 multiplied with pi, which is just 64 pi. 64 pi. Okay, so the next problem, please, I don't want this video to be above 15 minutes. Okay, where R is a sector of a circle with R is a sector of a R is a sector of a circle with a radius of 3. It's subtended by the angle of pi r. So when it says subtended by the angle of, you don't need to include any of these. Okay? You don't need to include them. No need. Because the angle is already given to us. So the radius is 3, and the angle is a third of pi. So I'm just going to write that down. R is equal to 3, and A is equal to a third of pi. Okay, and the question was the same. So, oops, not there. Over here. Okay, so it's x squared plus y squared dA. Now that is just going to be theta 2, theta 1. The radius was from 3, so origin of the circle, which is 0, ranging towards 3. So that's just going to be 0 to 3. X squared plus y squared dA. You already know r dr d theta. So x squared plus y squared is just r squared. So we're going to use the first integral, r squared multiplied with r. That's going to be 30r to the power of 3. Now, we're going to differentiate this with dr. So 3, 0 differentiated with respect to r, that would give us, since there's no constant, 1 multiplied with the power rule. So that would be r4 over 4. That would be 27 multiplied with 3, 21, 3, 81, 81 over 4. So since it's 0, it would just be 0. And then that is multiplied with the angle of 1/3 of pi. So the next integral is going to be theta 2, but theta 2 is just going to be the angle. So the angle itself is pi, 1/3 of pi. So it's going to be from 0 to 1/3 of pi. So that's how we're going to get that. And we're going to integrate 81 over 4 in respects to theta, d theta. So that is going to be equivalent to 81 over 4 shifted there because it's a constant for 3, 0 d theta. It's going to be 81 over 4 multiplied with pi over 3 minus 0 pi over 3. And that would be 81 pi over 12. But some people can also simplify it. So if your question also says simplify, I think you can also simplify this by 3. If I'm not wrong, 27 times 3 is 81. Yes, so it should be 27 pi over 4. Okay, so yeah, that's all I wanted to talk about in this video. Now you have a very good understanding on how polar coordinates and all work. So yeah, thank you all. Bye.